Hey there, welcome to another short video. Well, I can say it's a short video before knowing how long it will be. Welcome to another video on solving a LeetCode problem with APL. In this video I'm going to tackle problem 6 because one of you requested that I solve this problem on GitHub, and so yeah, why not? So let's go ahead and do it. Alright, so yeah, problem 6 is right here. I prepared this, so now let's see what it says. So the string PayPal is hiring is written in a, wait, what? In a zigzag pattern, is it? Oh, sorry, I confused myself. So the string PayPal is hiring, so this is a regular string, is written in a zigzag pattern on a given number of rows like this. So this is the zigzag pattern, so it goes down, then across, then down, then across, then down, then across, then down. And if we read it line by line, this is what we get. Oh, okay. Okay, and then it says write the code that will take a string and make this conversion given a number of rows. So it takes the original string, the number of rows, and returns the zigzag string. Okay. Okay, I see. Alright, so how are we going to do this? Well, one thing we can do is generate these positions, pair them up with the... So what I'm thinking is we have this string. Now what I can do is I can try to compute the coordinates where each letter would go to, and then we could reorder those coordinates by, say, row, and then use grade to sort the rows, and then use the same permutation to sort the letters, for example. So let's see. I think I'm gonna go with the 4 rows pattern. So the original string is, if I manage to type it, is PayPal is hiring. So let me copy that here. And rows, let's say we have 4 rows, and the result, okay, so that's bad. N is the number of rows, and the result is, or should be, this thing. Alrighty, and then the correct pattern for visual reference is P space space I space space N, A space L S space I G, Y A space H R nothing, and then P space space I. Okay, so this is the pattern I'm going for. Alright, so how am I going to do this? Let's see, I need these many numbers. I'm trying to think of a nice way of counting. Okay, so maybe then what I can try to do is type some of the coordinates out. So the first one is 0, 0. The next one increases in row, so that's going to be 2, 0, and then 3, 0. So it goes up to the maximum, and then it starts going down. So it's 2, 1, 1, 2, 0, 3. And then it increases again, 1, 3, 2, 3, 3, 3. So that's the I over there, and then it decreases again. So it's going to be 2, 4, 1, 5, 0, 6. So that's this one, 0, 1, 2, 3, 4, 5, 6, and then 1, 6. So these are the coordinates I would like to generate. Let's be, yeah. So this is a simple pattern. These always add up to 3. This is a simple pattern. These add up to 6. Alright, so let's try to do the following. So n is 4. So that minus 1 gives me 3. So what I can do is I can look at these in groups of 3. And the first group of 3, and let's ignore the first one. So the first group of 3, the left coordinate keeps increasing. And then this defines the total, and the next 3 just shuffle things from the left coordinate to the right. And the next group of 3 just increases the left coordinate. And then the final group of 3 just shifts the totals around, and then the next group of 3 just increases the left coordinate, and so on and so forth. So I don't think I can't think of a way to do the whole thing at once, so we can work with the groups little by little. It's not the best solution ever, but it's gonna work. I guess. Yeah, so our solution is going to take the string on the left. So alpha is the original string, and omega is the number of rows. Actually, is it? No, let's do the following. So the string and the number of rows comes from omega. S is string, n is rows, and alpha is optional, and it's going to be the coordinates built so far. Now, the APL gods are going to judge me because I'm going to use some recursion, but it's going to be tail recursion, so it's not going to be terrible performance-wise. Or actually, no, I think I can do the whole thing at once. So it's groups of 3, right? So the size of the group is, so first let's split the right argument. Now the size of the group is G, which is n minus 1. That's the size of the group. Now, how many groups do I need? So I need as many coordinates as the length of the string, and the first coordinate is given by the 0, 0. Right? And then I always have the sequence of increase left, decay to the right. So these are chunks of 6. So I need to take this and take twice the size of the group and divide the total size of the string by that, and I'm gonna need these many groups. This is I need as many groups as this, so many groups. So number of groups that is enough. So I'm going to build excess coordinates, or coordinates in excess, and then in the end I take the size of the string and I use that to take from the coordinates, because I'm not going to need everything. So, oops, sorry about that. We are not going to be using recursion, so alpha is no longer optional. It doesn't make sense to talk about alpha like that. So these are the many groups that we need. Now, how do we build these groups? Excellent question. Let's see. The first thing we need to do is think about how to increase these patterns. So what I'm going to do is I will think about these little patterns here. Yeah, okay, so iota mg, maybe I should be playing around in here and then coding everything so that we know, so that we see what's going on. So S and N, so mg is the ceiling of 2 times the number of groups. No, I haven't defined the number of groups yet. So mg is the ceiling of 2 times the number of groups into the... So I know that I need 3 groups of 6 coordinates. That's plenty, because I'm going... In actuality, I have... What did I do? Oops. How did I open this? In actuality, I need 1 group of 6, 2, and then just a little bit of the third. So 3 is more than enough. Great. Now that I have these, I'm going to enumerate them. Yeah? And now I'm going to build this portion of these groups. So the portion where the right coordinate is constant and the left coordinate increases from 1 to 3. So how do I compute the right coordinate? Well, it's going to be the number of groups, or the group size times that. So these are the right coordinates. And now I need to pair these with 1, 2, 3. So that's going to be 1 plus the size of the group, iota. Oops, I did this the wrong way. Wait, what am I trying to do? Let's think. Right, so what I want to do is I want to take... Let me show you both together. Yeah, what I want to do is I want to pair these up with this. So it's not a... I don't want to do an each. I want to do the outer product. What? I mean pairing. Why do I say something and then write something else? So this is the pairing, but this is not in the order I wanted. So if I swap this and then revel, these are some of the coordinates I care about. This is the beginning of the first group. Except the coordinates themselves are swapped. Okay, so this is the beginning of the first group, this is the beginning of the second group, and this is the beginning of, this is the beginning of the third group. Now, actually, it might be useful to store these as such, because now, from the last column, so these are the beginnings of the groups. So the beginnings of the groups are these things. Okay. Now what I can do is, from the right column of these things, I can do a... let me think. Yeah, I can do this. I can sum each. So now I know that... now I should probably go and grab those just to show you what I'm talking about. So what I've built was this portion right here, and the one that starts here. Now what I want to do is I want to build this one, and the way I do it is, or could be, for example, by taking these and then adding a couple of vectors that represent differences. So I could, if I have the 3, 0, I could add it to the vectors -1, 1, -2, 2, and -3, 3. And this needs a... yeah. Right? So now if I have all of these, if I take this, so the right column of BG, so the right column of BG, and now I want an outer product. Wait, I did something silly again. The 3, 3. Why was this silly? One, 3, 2, 3, 3, 3. So where's the 2, 4? Oh, right, it was not silly, it's correct. Okay. So now notice that this thing, so let's take a look at this expression. Let me put the, so these are the coordinates again, but let me get rid of this line because it's in the way. So that it's easier to see things. Alright, so notice that this section corresponds to this section. So it's the second half of the first group. And if I scroll right, let's look at this. So the 241506, it's in here, 241506. So now I need to take the beginnings, which are these, and I need to catenate them with this. So if I take this and I catenate it here, this is what I get. And now if I revel, I get the coordinates, except I have too many. So then I need to only take what I need, and then we need to do some shuffling. But the thing is, this was hard-coded. So how do I build this pattern? First we do a, so we need these many, which is the size of the group, and then we add 1 to that, and then we need to take -1, 1 and multiply with that. So we can replace that by this, and there you go, we have the coordinates. So these are the coordinates we need, and it's actually as many as in the string. So we do a take from that. We need to append the 0, 0 because we have been ignoring it so far, and that's what we have. So these are the coordinates. Now let's check that I'm not writing rubbish, and clearly I am. What did I do wrong? I forgot one of the revels. Yeah, so first we revel, only then we add the 0, 0. So these are the coordinates, right? Now what we need to do is shuffle these around based on the row, and the row is the left argument. So what we can do is we can mix them, and then we can take the left column, and then we need the grade down because we want the lower columns to come first. And this is a permutation. So this permutation comes from the coordinates, and I didn't define CS in here, so let's copy that, paste it here, and then so this is a permutation. Now I can take the string and I can shuffle it around. Amazing. So that's what we need. P gets the grade down of the left column of the take of the coordinates, and then we take the string and we return it shuffled. Let's see if this is correct. I hope it is. Oh, right, we can check it because we have the result in. No, I got it wrong. What did I get wrong? P-I-Y. Why did I get that Y there? Let me check the coordinates and make sure they are correct. Let's paste the other ones here. Where are they? They're in here. So these are the same, aren't they? Yes, they are. 24150616. So I must have done something else wrong. The number of rows is 4. PIN. Did I compute the wrong thing? 0, 1, 2, 3, 2, 1, 0, 1, 2, 3. Oh, this is so silly. I went through all the trouble of computing the coordinates when the only thing I really care about is this pattern. That's a bit ridiculous. Fine. Oh, right, I don't want to grade down, I want to grade up. of course. So this is P and then S of P, and then this matches the results. Alright, so this was a ridiculous solution to this problem. We got where we needed to be, except we took a very long path to get there, because the only thing we really care about is this pattern right here, because this is the one that determines how the grade works. So as an exercise for the, I'm gonna say, I was about to say listener, but I don't know, the person watching this, just stop the video and solve this again with this pattern, because this is much easier to solve. This pattern should be easier to build. The iota and the reverse just goes up and down. Well, I'm too tired from all of the useless computations I made, so I leave it as an exercise to you, and just feel free to comment your solution below. Bye.